on Facebook. Good evening, everyone. I'm Tiffany Wolberg with the Ward Beecher Planetarium. Coming back another week with our Keep Looking Up series. I'd like to introduce some of my amazing coworkers. This is our engineer, Kurt Spivey.
Hey ho.
And then our students today, Eleni.
Hello.
Jenny.
Hi.
And Nishan.
Hello.
We have a fourth student, Howard Hale, and he may join us a little bit later, but he is busy today, rightfully so, because he graduated today. So congratulations to Howard Hale and to the whole class, the whole YSU class of 2020. We had a virtual commencement today with hopes that they'll have some sort of in-person celebration later in the fall. I hope that that can work out because they certainly deserve to be celebrated. It's a huge accomplishment. I feel like my undergrad was one of my greatest accomplishments too, so congratulations. And we also wanted to give you guys a quick update about the planetarium as things are reopening in the Ohio State area. We're just wanting to give you guys an update about the planetarium. The university does remain closed to students throughout the summer. So we currently have no plans for in-person summer programming. We're talking now about what our fall is going to look like. But we do hope to continue these every week. And we really enjoy touching base with you guys each week, hearing your questions and your comments, and even reaching out to further audiences, people who aren't from Ohio. You guys are joining us from all over the world, and that is just really special to us. So if you aren't from Ohio, let us know in the comments. We'd love to say hey to you. Our show today is going to be focused on the planets nearest to our planet Earth. So we'll first start with our star talk, as we do each week, to talk about some of the latest stuff in the sky. If you're in the US, the sky doesn't change too terribly much. So even if you're not from Ohio, you should be able to get something out of this. And that'll be led by Kurt. Then we will talk a little bit about Venus. I learned a lot. I'm going to be leading that. I learned a lot in this, preparing this talk for you guys. So I'm excited to share it with you. And then we're going to finish things off with our student, Jenny. She's going to talk all about Mars. I know she's really excited to do that as well. So I'll stop talking at you. I'm going to turn this over to Kurt, but please feel free to ask questions at any time in the comments on Facebook. Our students are here to relay your questions. They will either answer them in the comment section or they will relay them to Kurt or I or whoever's speaking. And we love to have discussion and interaction with you. So please feel free to ask any questions. And if you missed this show or you know someone who might want to see it, it's going to be posted on Facebook and also on our YouTube at WB Planetarium. WB Planetarium. Okay, Kurt, I promise I'm done. Go ahead.
No problem. By the way, students, if somebody does have a question for me, feel free to butt in because I'll be concentrating and I won't be able to see you putting your face up, letting me know I've got a question to answer there. So we are talking about the nighttime sky. This will be a little different than the previous weeks. Every week we try to have somebody different do the star talk so we can get a different perspective on what we're seeing in the nighttime sky. I'm going to do a couple of basic things, but there's something else I want to talk about, which I'm going to get to. First off, sunset tonight is all the way at 8:28 p.m. here in Youngstown, which means you won't see anything in the sky right at that time because the sky is still too bright. Won't be until about, say, 9 o'clock that if you look out at the stupid snow outside, you won't see anything outside tonight. But you wouldn't see, if it was clear, you wouldn't see anything in the nighttime sky until about 9 o'clock. And it wouldn't be until about 9:30 that you're going to see everything there is to see. So if you look down here at the bottom, you will see my time is 21:30, which is 9:30 this evening. And as I look over here on the left side of my screen right here, you'll see the brightest object in our evening sky right now. This is what Tiffany will be talking about in a little while. that is Venus in the nighttime sky. Venus is the third brightest object in our sky. It has been high in our evening sky for most of April and May. But now it's beginning to be lower and lower. It is going around, I can't remember if it's going in front of the sun or behind the sun from our point of view, but we're going to lose it in a couple of weeks where we won't be able to see it at all. And then by the end of June, it's going to pop back up in our morning sky. So if you get a chance over the next week or so, it's a good time to catch Venus before it disappears from our evening sky. But it doesn't do me much good to tell you that Venus is right there because you don't know where there is. But I can help out with, let's see here, it's doing that. There we go. I can help out with these things. They are called cardinal points. So if I come around like this, you can see here is west over here. Here is north here. Venus is in the northwestern sky. Last clear night we did have, I did notice this bright star nearby to it. That is actually the star Capella in the constellation Auriga the Charioteer. And it's very bright as well. So you will see those two together in that part of the sky. Now, outside at night, of course, you don't have a big N in the sky. For those of you who watch our planetarium shows all the time, you know what I'm about to do. We're going to help you find things in the nighttime sky. And to do that, you want to find a very famous group of stars that's right up here. We have 3 stars that make a handle and 4 stars that make a cup. And for all my planetarium veterans out there, you probably recognize that. That, of course, is the Big Dipper. And the Big Dipper is important for a couple of reasons. First off, it's bright enough that even when you're around the lights of a city, you can still see it. More on that in just a minute. Second of all, the Big Dipper is always going to be up in this part of the sky someplace. It never sets. So since it is always up there and so bright, we can use the Big Dipper to find the most important star in the sky. What we're going to do is take these 2 stars at the end of the Big Dipper's cup. Now outside tonight, of course, you don't have a little arrow that you can use to point up at the sky like this, but you can do this with your eyes as easily as I am with my cursor. Just draw a line from the star at the bottom of this cup through the star at the top of the cup, follow that across the sky. And the next bright star you're going to come to is right here. That star, of course, is called Polaris, which you probably know better as the North Star. And if I pan down, you can see it is directly over the end. The North Star, Polaris, is directly above the North Pole of the Earth. That means the sky above us appears to move from our point of view, but it really isn't. It's us that moves that makes it appear like the sky is moving. The Earth turning is what makes the sky appear to turn up above us. So since the North Pole points at this, that's the top of our planet's axis. The whole sky appears to pivot around that point in this direction. I'll show you that a little bit more later. But tonight I want to concentrate on the Little Dipper. So I'm going to zoom in a bit here to the Little Dipper and let you see what that looks like in the nighttime sky. There's the Little Dipper right there. It's not the brightest constellation in the sky, but since it is the home of Polaris, it is really easy to find if you're at a dark enough location. Speaking of which, I can do something that you can't do here in Youngstown. I'm going to get away from all the light pollution so you can see that a little bit better. And I'm going to talk about the stars that make up the Little Dipper, because let me go back into the atmosphere. You can see how many more stars pop out when you get away from the light pollution. Well, we have something that's called, astronomers rank stars by how bright they appear in the sky. The very brightest stars we call first magnitude stars. There are 26 of those in the entire sky. And with this up here, Capella that I pointed out earlier is a first magnitude star. This one down here is a first magnitude star. That one's called Vega. I'm going to make that go away. And now I'm stuck with that outline. I can't really make that disappear without turning all of them off. Up here we have Castor and Pollux. Those are both first magnitude stars. This is Procyon over here. Some of those first magnitude stars we never see here in Youngstown. They always remain below our horizon. And others we only see in the spring or the fall or the summer. The Little Dipper actually does not have any first magnitude stars. If you look up here in the corner, you will see that Polaris is magnitude 1.95. Anything above 1 we call second magnitude stars. The dimmer a star is, the higher its magnitude number. Now, this was all invented by a Greek person a long time ago, before they had telescopes and they had cameras where they can measure down to decimal points exactly how bright a star is. We've only been able to do that for about the last 30, 40 years or so. Our magnitude system is based on what your eye can see, which, this is going to sound weird to somebody, your eye works on a logarithmic scale. So the difference in magnitude between a first magnitude and a second magnitude is 2.5 times brighter or less bright, however you're looking at that. I'm not going to go into logarithmic scales. That's something for Dr. Durrell when you take the 1504 class at YSU. I'm not going to go into that tonight. But Polaris is a second magnitude star. Over here, this star is called Kochab, and this one is called Phaircad. Kochab is just a little bit dimmer than Polaris. It's 2.05, and Phaircad is a third magnitude star, magnitude 3.00, when you're looking at it in the nighttime sky. Now, if you are around the light pollution in Youngstown or any city you're in, and I don't know if I can do that right here, those are the only 3 stars you're going to be able to see. When you are around the lights of a city, you can only see down to third magnitude stars. So light pollution really does affect what you can see in the nighttime sky. Now, if you get out at a very dark place, the Little Dipper is a very, very handy thing to know. Because, as I said, you've got 2 second magnitude, a third magnitude star. If we look at this one here, that's Gamma Ursa Minoris, easy name to remember. That is a fourth magnitude star, 4.25. This star in the handle, oh, this one's actually a little bit brighter. This is 4.2. This one's 4.25. So those are both fourth magnitude stars. This one here is closer to a fifth magnitude star. And this one over here in the bottom of the cup is almost a, well, if you look here, it goes to almost sixth magnitude. So the reason I'm telling you this is the dimmest stars that you can see without a telescope in the nighttime sky from a dark location are sixth magnitude stars. So depending on how many stars of the Little Dipper you can see, you get something we call the limiting magnitude of the stars. If you can only see Polaris, Kochab, and Phaircad, you're in very light polluted conditions. The more stars you can see, the better conditions for viewing the nighttime sky. And now that we have CCD cameras and can take accurate measurements of the light coming from these stars, we can get some pretty interesting numbers when we're looking at things in the nighttime sky. So I'm going to bring this down just a little bit. And
hey, Kurt, we have a question.
Okay.
It's a great question. Our friend Haley, oh no, I just lost it. Haley just asked, here we go. What is the brightest constellation? How do you determine what is the brightest constellation? Do you take the collective brightness of all the stars, or is there some other process?
Well, we don't actually rank constellations by how bright they are. I'd say the easiest to spot constellation in the nighttime sky, we've just lost over in the western sky. You can actually see the top star of it right here. That is Betelgeuse right there in the nighttime sky. Orion the Hunter has 3 first magnitude stars and 4 second magnitude stars that make up the main body. So it is one of the absolute easiest to identify constellations in the entire nighttime sky. Unfortunately, it's going in behind the sun now. We won't see it again until about November. But I'd say if you're going to say brightest constellation, that would probably be how I would rank that with that particular nomenclature when we're talking about the constellations up there. However, there are things you can see in the spring and the fall and the summer that have bright stars in them too. The shapes overall, though, might not be as distinct as Orion is in the nighttime sky. Just a couple other things I want to show you in the nighttime sky, though, in this part of the sky up in the north. If we draw our line through Polaris and keep going, we're going to hit another fairly dim star right here. It's actually magnitude 4. This we find in the constellation of Cepheus. Oh, I missed that by one. I guess I wanted to hit that one, which is a 3rd magnitude star. It's a little easier. Cepheus is a king who lived in Ethiopia. If you've ever heard my fall star talk, that he's all part of the Clash of the Titans story. But he is what we call a circumpolar constellation as well. He's always up there in the nighttime sky as well. The reason I point out Cepheus to you, though, is some of you, we got all excited a few weeks ago because there was a comet in the nighttime sky called Comet Atlas. And unfortunately, it fizzled on us. I'll get to more on that in just a minute. But it actually, what's left of it is right here in this section of the nighttime sky, just above Cepheus, right there. I now am going to go ahead in time. So we're going to watch this little thing down at the bottom. And I'm going to do this a jump way. I'm going to use my plus key, if I can. Let me see if I can figure out how to do this. Oh, I need this one. There we go. So we're going to hop ahead here several hours. And actually, I'm going to move over to the eastern sky here. And there's the moon. When we come over to the east, this is 1:30 in the morning. There's the moon right there. I'm going to jump just a couple more hours. Jupiter and Saturn have appeared in our evening sky. And now so has the other member of our little group that we're going to hear about tonight, our other neighbor in space, that is Mars. As you see, it is not as bright as Jupiter. It's about as bright as Saturn in the nighttime sky. And you can actually draw a line from the moon through Jupiter, through Saturn, and down to Mars. This is a line we call the ecliptic. All the planets appear to follow this across the sky. I'm not talking about that tonight, though. I'm going to go to 5:30, and that's kind of bright. Let me go back an hour. 4:30 will work. Let me go ahead a bit in time this way to 5 o'clock in the morning. A little faster than that. And the reason I'm doing that is even though Comet Atlas, it was getting so bright so fast back in February and January that we thought we might have a comet as bright as Venus in our nighttime sky. Unfortunately, it fizzled, and I'll explain why in just a minute. We do have a consolation prize in the nighttime sky, though. If we come up here, here's the summer triangle here. So what I'm looking for is right here. We have 4 stars in the sky that form, well, that's Andromeda. Let me do this one. There we go. They form this shape right here. That is the Great Square of Pegasus. And just down from the Great Square in this part of the sky, we have another comet in the nighttime sky. It is called Comet Swan. And I'm going to change my sources here. Give me just a second. And we're going to talk about our 2 comets in the nighttime sky. There we go. Takes it a moment for my PowerPoint to come up. First off, this is what's left of Comet Atlas. The Hubble Space Telescope took a couple of pictures of it, and it had been a nucleus and was getting bright. Now we know the reason it was getting so bright so fast is it was getting ready to split apart. In this image from April 20th, you can see at least 8 separate pieces, and then on April 23rd, it's now in 10 pieces. So instead of being about the brightness of Venus, which is about magnitude 0 or -1, it is now magnitude 10. So you do need a pretty powerful telescope to find it now, and you need tools like the Hubble Space Telescope to watch the disintegration. This happens, though, because basically comets are leftovers from the beginning of the solar system. They're big, dirty snowballs out there in space that got thrown out into the outer reaches of the solar system by the gravity of Jupiter, basically. But every now and then something nudges one of them and they come swooping back in toward the sun. But when you get a big dirty snowball near the sun, it's going to melt. Now, if it's a big enough one or it's cold enough, it's only going to melt a little bit and it's going to make that nice tail and then go back out and come back many times. Other times, like Comet Atlas here, it gets too close, it gets too warm, and it breaks apart. But this is Comet Swan, and that is a gorgeous picture. This was taken by the Siding Spring Observatory in Australia, and this is what we call a time-lapse photography. They took many pictures over several minutes. That's why you see so many background stars, and you get to see this gorgeous long tail on Comet Swan in the nighttime sky. Unfortunately, even with a pair of binoculars or a telescope, you'll probably see something that looks like this in the nighttime sky. This also is a picture of Comet Swan from an amateur astronomer. And once again, you can see how grainy the background is. They took this picture over a couple of minutes of exposure, so you can see the green. It will appear greenish in the nighttime sky, but it'll appear kind of like a fuzzy star to you. This is where Comet Swan is. We are on May 9th, so here's the Great Square of Pegasus. This is Pisces down here. And so right now, Comet Swan is in the constellation Pisces. It's heading this direction across the sky. Unfortunately, this is only a small consolation prize to the fact that we lost a comet that would be almost as bright as Venus. Its close approach to Earth is going to be around May 20th, and at that time, it is going to be 5th magnitude. So once again, if you want to see it without a telescope or a pair of binoculars, you're going to have to be at a really dark place. The good thing there, though, is if you do have a telescope and you have a chart like this where you can find it at 5th magnitude, it will be pretty easy to find even in relatively small telescopes. You're not going to have a big camera rig or anything like that to see it. The problem we have here is we are heading towards summer. So sun rises earlier and earlier and earlier. So as you saw when I was doing my thing in Stellarium there, the sky was getting brighter and brighter toward 5:30. You really have to go out 4:30 to 5:30 if you're going to have a chance of seeing this in the nighttime sky. And you're going to want to do it over about the next 10 to 15 days. It's going to be highest in our sky on May 25th, and then it's going to start turning away from us and diving into the glare of the sun. It already has gone by the sun. It's on its way back out into space. This was discovered actually by a satellite that is monitoring the sun. It found this thing, and the name Swan comes from that satellite. So we only have a small opportunity, and it's not super bright, but we have not had a comet this bright in the northern hemisphere in almost 20 years. So we got to take it when we can get it. Now, unfortunately, it's a shame Atlas had to fall apart on us, because this would have been May 22nd. If Atlas had stayed apart, it would have continued diving through Cepheus and heading this direction. And on May 22nd, we would have had Comet Swan here, Comet Atlas here, and if you look down here, there's a third comet inside. This is a really, really faint one. You need a pretty powerful telescope to see it. It's called Pan-STARRS by actually an asteroid hunting program that's out there. And it would have been in the sky. So we would have had 3 comets in the same part of the sky at the same time on May 22nd if Atlas had held together. But, you know, you can't have everything. And they often say comets are like cats. They have tails and do exactly what they want. So that isn't much on the stars tonight. I wanted to talk about the comets, but shared in our comment section, I should say, we do have a link to something called skymaps.com. This is a printable PDF map of the nighttime sky. And I did hear it's actually going to turn into May at the end of next week, and you can get outside and it'll be warm at night. And you can look up at the nighttime sky. So I encourage you to go there, print out one of those PDFs, go out and take a look up at the night sky. And back to you, Tiffany.
Thank you, Kurt. That was great. I want to point out while we're transitioning from Kurt's talk to mine, that Howard has joined us for the talk. So,
congratulations, Howard!
Yay! Congratulations, Howard. Will you say hey to us? You can unmute.
Hello. Hey, thank you.
We congratulated you early before you got on. We told everyone you graduated. It's been a real pleasure to have you as a part of the crew, and we are missing some of our traditions. We have traditions in the planetarium of things that we do for our graduating seniors. We have a formal, silly process where we like remove their name off of our doors. And anyway, we're gonna have to miss some of those traditions with Howard, and that's really sad because he deserves a lot of recognition for the work that he's done in the planetarium field. And I hope to see you continue on in this path, Howard, and thanks for joining us tonight. Anything you want to say?
It's been really great working at the planetarium. I really enjoyed it. It's definitely one of the best jobs I've had, and I've only had 2 jobs, so this topped my first job by literally miles. And I'm gonna miss it. I'm gonna miss it a lot. I wish I could stay forever, but hopefully I'll be able to stay in the field and see you all again at conferences and everything.
I think you're going to move on to bigger, better things. All right, well, let me switch back over to my talk. I'm going to share my screen here, and we're going to talk all things Venus. Okay. All right, so here is, I just have a few pictures of our closest neighbor. Venus is the second planet from the sun. It's also the closest planet to planet Earth. And another interesting thing is it's the only planet named after a woman. Venus is the name of the Roman goddess of love and beauty. So it also is the second brightest object in our nighttime sky, only after the moon. And it's so bright, in fact, that if you have really dark skies, as Kurt was mentioning, you actually can have, it can actually cast shadows. So you actually could see your shadow from the light of the planet Venus if you had very dark skies. Probably not in Ohio unless you go to a dark sky park. We've been watching Venus longer than like probably any other planet. In fact, there have been there's evidence that we have been tracking Venus's motions through our sky as early as 2000 BC. That was the Sumerians. Now, most ancient civilizations saw Venus in the sky as either a morning star or an evening star. So they saw this bright star that would appear and reappear in the morning. And then sometimes there'd be a bright star that would appear, disappear, then reappear in the evening. Not all civilizations connected that it was the same thing. And now we understand because it's going around the sun. It's closer to us than the sun. Sometimes it appears on the morning side of the sun, sometimes on the evening. It seems really straightforward to us, but keep in mind that this was thousands and thousands of years ago. We've been watching Venus for a really long time. This is before we even understood that the sun was in the middle of our solar system and all of that. So the pictures that you're seeing here on the right is the most photorealistic picture that I could find. A lot of the images you're going to see of Venus are colorized to help highlight different features. So this picture, you can see thick clouds, and that's mostly all that you can see of Venus from Earth. To the left here is actually a picture taken through a telescope by an amateur astronomer, and it is colorized a bit so that you can see the cloud, it sort of highlights the detail of the clouds in the sky, or in Venus sky. And I also want to point out that it has a phase. So both Mercury and Venus have phases. Just we see phases of Venus, just like we see phases of the moon. So if you saw this and this was a moon, you would say that's a gibbous moon. So this is Venus, so we call that a gibbous Venus. And this was actually one of Galileo's sort of hard evidence of proving that that things did not orbit the Earth, that the planets and other objects orbited the sun, this heliocentric model, which was first developed by Copernicus like hundreds of years before. I think it was the 1500s, and then Galileo was in the late 1600s. So he looked through his telescope and saw that Venus was not big and bright and round as we see it just in the sky. It had went through phases. Even though it kept roughly in the same part of our sky each night, the phases changed. And that would only happen if it was moving around something that was not the Earth. That's about all we learned about Venus since the 1700s. So we learned that it had a cloudy atmosphere and then had phases. And that's about all we knew for a while. It's kind of wild how close Venus is to us and how little we actually know about it. But that's due to this thick atmosphere you're seeing here. It has, the atmosphere is very caustic. It's made of mostly carbon dioxide. I think a little bit of nitrogen and then some trace gases. It is incredibly hot. It is the hottest planet in our solar system. It can reach up to 900 degrees Fahrenheit. That's like hotter than a pizza oven, okay? Really, really hot. And that's due to the sun's warmth is getting trapped underneath that atmosphere. The surface of Venus is also highly pressurized. If you were on the surface, walking on the surface of Venus, it would feel, it would have like 92 times greater the gravity than here on Earth. So you would be 92 times heavier on Venus. You would pretty much just collapse under your own weight. It's not hospitable for humans at all. That would be equal to about 3,000 feet underwater. So if you were 3,000 feet underwater, that's how much pressure you would feel on the surface of Venus. Not a place I want to visit, but I'd still love to learn more about it. It's a world of extremes. It's also sometimes called the sister planet to Earth because it's very similar in size to Earth. It's about 82% the size of Earth. And it's a terrestrial planet, it's a rocky planet like Earth. A little bit more about some of the basics of Venus. Oh yeah, this isn't gonna play, so I'm gonna come out and play it like this. Okay, I love this video. It's the best. Thank you, James O'Donoghue from NASA for making this, because it's so cool. This shows you the rotation speed of all of the planets in our solar system. It also shows you the angle at which they rotate around the sun. So we've arbitrarily said that this is up in 0 degrees, and that so Earth is tilted about 23.5 degrees off of that north latitude that's like perpendicular to the plane of our solar system. If those words didn't make sense, that's okay. Mercury, you can see Mercury moves really, really slow. Jupiter moves really, really fast. Venus moves very slow. It only rotates, it only spins around one time every 243 days. That is, it rotates so slow that it actually goes around the sun. It goes around the sun once every 224 days. So a Venus day is a little bit longer than a Venus year. Pretty cool. You can also see that Venus rotates backwards. Sometimes that's called retrograde motion as well. It's just a fancy word for it looks like it's moving backwards to apparent motion to us. So if we're spinning in one direction, it looks like Venus is spinning the other direction. Another way to think about it is that Venus's rotation is basically upside down. It's almost 180 degrees, 177. So it's rotating relative to Earth almost completely upside down. So it looks like it's spinning in a different direction, which means that the sun would rise, I think it's once every 100 days or so, in the west in Venus sky, and then would set in the east. Wild. Let me see if there's anything else I wanted to mention there. I think, oh, so this is, again, we've kind of first discovered the rotational speed of Venus in like the early, or was it 1950, something like that. So within the last 100 years. And then everything else I'm going to talk about has been discovered since like the 1960s or so, when we started to actually send landers and rovers and, or sorry, landers to Venus and orbiters to Venus. We have not had a rover. The longest lasting lander, we have landed on Venus, but the longest lasting lander it lasted for, I think it was 110 days or something like that. It was, no, I'm sorry, 110 hours. It was a couple of days. Let me check my notes. It was not very, very long at all. I'm sorry, not hours, minutes, 127 minutes. So the longest thing that we've ever sent to Venus that lasted about an hour and a half or 2 hours. Math. Yeah, that's right, 2 hours. And it died. It's because even the toughest thing that we could build totally broke down through the harsh conditions of Venus. If you try to research a little bit about Venus, and my research to try to learn something new about Venus that I could share with you guys, I ran into the words hellish and hellscape a lot when talking about the surface of Venus, because I mean, that's the best way to describe it. It's incredibly hot. It's gonna look a little yellow due to the clouds. And the pressure is immense, and there's sulfuric acid in the atmosphere. Even metal will break down and crumble under pressure like that, in conditions like that. So it's a huge challenge to understand more. Even though Venus is the closest planet to us, it's a huge challenge to learn more about. Here, we'll go back to this view. So these are two images taken of the surface of Venus, and the way they were taken was using radar, so radio waves or microwaves. These radio telescopes, you see, they have those huge satellite dishes that look really deep into space, or can look at different light than our eyes can see. So this was data taken using light rays that could penetrate Venus's atmosphere, and so that we could actually see the rocky surface below. And see is in quotes. So we took this data and then sort of moved it into the visual range so that we could try to interpret it with our eyes. So this is not at all what the surface of Venus would look like. It's data, okay? So you can see peaks and valleys. This image to the right here, the blue is the low regions of Venus, and then the red, orange regions are the higher regions. So it has terrain, it has highs and lows. It's rocky. There's no way that there could be liquid water on the surface just due to the temperature. It's way too hot. The water would boil off. But based on what we know now, which is not a lot, scientists do think that Venus could have had like large shallow oceans on its surface long ago. And then as it's a greenhouse effect. So as the atmosphere got thicker and it warmed everything, the planet warmed up, that water began to boil off. And we see a lot of carbon dioxide in the atmosphere. And so that's one guess as to why there's so much carbon dioxide in the atmosphere. So that's the surface. Let me see. I feel like there was something else I wanted to mention with that. I guess I just want to mention that the reason why the picture on the left is this color is that's sort of the best guess as to what the ground would sort of look like. The clouds, the yellowish clouds, would give the surface of Venus this sort of orangish gold yellow color. Okay, and then I got really excited when I saw these. I've actually never seen pictures of the surface of Venus. I just never Googled them, I guess. I knew that we had landers that landed on Venus, and I knew that they only ever lasted a couple of hours, but I didn't realize that they had cameras on them and that the cameras lasted long enough to take pictures. That's so cool. Another thing that we don't talk about a lot is that Venus was a big part of the space race. in the 1950s, 60s, 70s, during the Cold War, when we were trying to take our wars off the battlefield and up into space. We talk a lot about the moon and who got to the moon first and who got into space first and all this. But we also raced to get to Venus. So this was a Russian mission. It was a series of orbiters and landers. It was called the Veronera mission. So there was, I think, 14 or 16 in all, over about 15, 20 years. This one was the first one that landed successfully on the surface of Venus. It did have a parachute failure, and the parachute broke. It started hurling down to Venus's surface, and it was going at a pretty fast speed. I only know it in meters per second. It was like 16 meters per second, but that's real fast. So imagine like a pretty intense car crash. And it survived. Like, it landed, it hit really hard, and it fell over, but it still survived for about 23 minutes. And they took, these are the first images ever of the ground on Venus. And this is one of the last. This was in 1984. And the Veronera 13 was also the one that survived, the lander that has survived the longest up until now at 127 minutes. Crazy. So that's why we don't know too much about Venus. It's just too hard to land there. We plan, NASA, not me. I know I'm just a groupie. I'm not actually part of NASA. I can't claim this, but NASA plans to build a rover that their ambitious goal is that it would last for 60 days. So the last lander that has landed on Venus was in 1984. We've had lots of orbiters go and look and take satellite images and things like that. We've learned a lot about Venus from space since then, but that only lasted a couple of hours, and NASA wants something to last for 3 months, 60 days. And they're calling it the Long-Lived In Situ Solar System Explorer, or the LLISSE. Please find a better name. That's bad. But in spite of the super long name, it's going to be pretty small. Okay, it's only going to weigh maybe like 33 Earth pounds. And it's going to be, I think they're using sort of the ideas of the CubeSat models where everything is sort of tiny and compact. And they're looking at different form factors right now. It's still really early in the design process, so there's not a whole lot of information on it, only that they plan for it to last. They want to land on Venus, be there for 60 days, and their goal is 2023. We'll see if that happens by 2023, but it would be really cool to go back to Venus and learn a little bit more. Since then, people have, earlier this year, there were astronomers who were looking at archived data from Venus. And as we've learned a little bit more about volcanic activity on Earth by studying Earth, they went back and looked at the volcanic activity on Venus, because Venus definitely had volcanoes at some point. This photo here, this was taken in 1996 by the Magellan spacecraft. So not a lander, but something that flew over Venus and this is also radar imaging, I believe, to get through the atmosphere, to get through the clouds and see the surface of Venus. And you can see lava flow beds and pools. So this is cooled off lava from a long time ago, proving that there were volcanoes at some point on the surface of Venus. Okay, and this is kind of cool because only the planet Earth and a moon around Jupiter called Io is the only two places in the solar system that we see active volcanic activity today. There's proof on other planets that there's been volcanoes in the past, but not anymore. Well, these astronomers have looked at this archived data and seen traces of a substance called olivine, which is only present when the lava flow is fairly new. So it's suggesting that there might have been lava flows on Venus just a few years ago, which would ultimately mean that Venus is volcanically active. That is not definitive. We don't know that for sure, but there is supportive evidence that that could happen. And that just came out this year. So there's still so much we're learning about Venus. So going back to Venus, trying to land on it with the, we've made a lot of technological advances since 1984. So I'm sure we could probably make a lander that would last a little bit longer than 127 minutes. And
Tiffany, we had a quick question.
Yeah.
I think it's of this image that you have up right now. Erica Leonard her son wants to know what that shadow is, the long line.
The shadow here. I can't tell you for certain. I would guess, because of its shape, that it has some feature. It would be related to the spacecraft, the orbiter or the camera, because I don't think that it would have to do with the cloud shadows or anything like that, because you would see more shadows elsewhere. So I'm thinking it's an artifact of the data itself, if I had to guess, but I really don't know. I'm sorry. It's a good question. Yeah, so that's Venus. I hope we go back and visit one day with a lander and not with people. That's not going to be a good idea. Not my idea of a good time. Do we have any other questions or anything before we wrap up with Venus? I see Charles is mentioning that Venus is a great example of the greenhouse effect. Absolutely. Any water that was present on Venus in the past has long since boiled off due to the extreme heat from its atmosphere. Mark says he didn't know we had pictures of the surface of Venus either. Thank you for saying that, because I felt a little embarrassed that I didn't know. I mean, I knew we had landed, but I didn't realize we took pictures, and that's really, really cool to be able to see the surface of Venus when all we see are clouds from Earth. Okay, well, I will feel free to ask any other questions. I'll go to the comments and answer questions, but I want to hand this over now to Ginny. She's going to talk about our other neighbor planet, Mars.
Thank you, Tiffany. As you can see, I have switched my background, so now that I am on Mars, though I would actually need a suit because I would be freezing to death. So, Venus is really, really cool. But I really want to talk about Mars, and it's my personal favorite. I'm a little bit biased, but the red planet has a special place in my heart. So, Venus and Mars are next door to us in our solar system. But it's not like walking across the street and asking for a cup of sugar type of neighbor, right? Mars is, on average, 140 million miles from Earth. I state this distance as an average because the orbit of Mars is not perfectly circular. So sometimes we're closer to the red planet than others. But think about that for a minute, though. 140 million miles, that's an enormous number. So how can we actually think about this distance since it's so vast? Well, think about it this way. The fastest recorded speed of any spacecraft that has left Earth was about 36,000 miles per hour. It's not something you would do in your car, right? So if you hopped into your starship and left Earth at this astounding speed, it would still take you 162 days to reach Mars. That's almost half a year. So it's still pretty far for being just our next door neighbor, right? So now I'm going to show some images. So give me a second to switch to my screen. Okay. Okay. So the image that we're seeing here, I'm going to talk about here in a minute. I just wanted to get it up so I could not have to worry about it later. All right, so despite this large distance between us, Mars is still the most studied planet in our solar system. Well, besides Earth, of course. We've been studying Mars since the 1960s, almost 40 years. So what makes it so interesting? Well, I'm going to start at the beginning talking about Galileo. In 1609, he observed Mars for the first time using a telescope, which led to many other astronomers using telescopes for astronomical purposes. The first drawings of Mars that we're seeing here were from an astronomer, Christian Huygens, around 1659. These drawings showed this dark spot here, now known as Syrtis Major. It showed also that it had a southern polar cap here. And these are really interesting because these were the first geological features of another planet that were ever documented. So when he looked at these and he was documenting these, he noticed that about every day, this dark spot would reappear. So he was able to document the rotation period of Mars to about 24 hours, which is pretty familiar. So later on, he also noticed that the cap was rotating at the top, but he didn't see the northern cap because of probably the way that he was seeing it through his telescope. Though this must have really inspired him, because later on he published a book about what a planet would need to harbor life and speculated about intelligent beings like ourselves living on other planets. So Mars became a very interesting topic for sci-fi authors and artists closer to our time. But I mean, this also led many astronomers to ask that same question. How likely is life on Mars? Which I'm going to talk about later, right? But this also led to a growing interest in the study of Mars, right? So what do we know about Mars so far, right? We were talking about when we could see it in the nighttime sky. This is an image that I found where somebody had a very long exposure. It's a beautiful image where you can see Mars, Saturn, and Jupiter, right? So we noticed one thing about Mars is that it looks very red. Well, we do call it the red planet, but why, right? So the warm colors come from a process known as oxidation, or more commonly, rusting. Martian soil has a lot of iron in it, so when the iron is exposed to the elements in the planet's atmosphere, it rusts. But keep in mind that the atmosphere in Mars is very, very thin. Actually, it's less than 1% the pressure of Earth. So it doesn't have much protection from impacts like meteors, asteroids, or the harmful radiation that comes from the sun, right? Also, this means that the heat from the sun doesn't stick around very long either. So there are very intense temperature changes on Mars. It averages from negative 225 degrees Fahrenheit to 70 degrees Fahrenheit. These intense temperature changes cause very high winds on the surface and can lead to planet-wide dust storms, which we can see here. So on the left, we have this clear image of Mars. So we can see all of these geological features here. And on the right, we see when a dust storm was going over the entire planet. You can barely make out any of these features. Pretty cool. Also pretty dangerous, but it's fun to look at. So keep in mind that even though it's thin, the Martian atmosphere is primarily carbon dioxide. It does have a minuscule amount of oxygen, but we wouldn't be able to walk and breathe there without a suit, right? So we talked about the atmosphere and such, but let's talk about the planet itself, right? So Mars is about half the size of Earth. So if Earth was the size of a nickel, right, Mars would be about the size of a raspberry. And Mars only has 1/3 of the gravity that we feel here on Earth, kind of the opposite of the spectrum when we talked about Venus. So 100 pounds on Earth would only be 37 on Mars. I mean, with that, you might as well just stop dieting and just move to Mars. So also here at home, we have a really large, beautiful moon that we can see, and it has phases, right? Mars has 2 moons, Phobos and Deimos. Phobos is the largest of the moons, which we are seeing here, but it's still really small. Its diameter is only about 14 miles. Deimos is about 8 miles. So keep in mind that 14 miles is a little bit less than a trip from the Ward Beecher Planetarium to Warren. That's very small compared to our moon. So some cool things about Phobos and Deimos. Phobos is actually spiraling inwards in its orbit towards the Martian surface. So it'll eventually break up from the gravity or crash into the surface. And oppositely, Deimos, shown here, is going to leave its orbit eventually. So it seems like Phobos likes its home planet way too much, and Deimos just wants to leave. But fortunately, neither of these occurrences are going to happen anytime soon, right? So I mentioned geological features earlier. So there are a lot of really cool tourist destinations on Mars, you know, if we could always go there for a vacation time. I'm going to start with my favorite, oh, sorry, here's a size comparison for Phobos and Deimos, right? So they're very, very small, and they actually orbit pretty far away from Mars. All right, so now I'm going to talk about this canyon system, right? It's enormous. It's so enormous. It's great. I love it. It's my favorite part of Mars' surface. So it's called Valles Marineris, or Mariner Valley, right? And this is the largest canyon in this entire solar system. So it's very distinguishable. From side to side, it's 1,800 miles long. For comparison, that's the size of the United States from the East Coast to the West Coast. And it's about 4 to 5 miles deep in some areas. And for a comparison of that, the Grand Canyon is only about 1 mile deep. So it's enormous. It's very distinguishable. You know, we don't really know how this formed, but we speculate that it formed when like the planet was cooling and it was a crack between tectonic activity or something. Though I have some information about that, which I can give later. So not only is Mars home to the largest canyon in the solar system, it's also home to the largest volcano. But first, I'm going to show you some more images of this beautiful canyon system. It's like this takes up almost the entire part of the planet's surface here. It's literally enormous, and it's very, very cool to look at. Right, so here is an outline of the United States where you can see how large this actually is. Pretty amazing, right? Okay, so back to the volcanoes. This is Olympus Mons. So this is an enormous volcano, and that's an understatement. It's 3 times taller than Mount Everest, and from side to side, it's about 310 miles across, right? Now the volcano is extinct, but it would have flowed for thousands or millions of years in its time. And this isn't the only volcano that Mars has. There are different, it has multiple different volcanoes, but here, there's another range called the Tarsus Ridge, which is next to Valles Marineris, so you can see down here. So the Tarsus Ridge is literally just these 3 volcanoes here, and they're enormous too, but they're still dwarfed by this enormous volcano Olympus Mons. It is absolutely amazing. I love this image because you can see all of these really prominent features in one. So earlier I was talking about polar ice caps. So it has a northern and southern polar ice cap, right? And it's not just water ice. So I'm showing you the northern ice cap here. It consists of carbon dioxide, dry ice, and water ice. So they're very cold. Carbon dioxide freezes at negative 337 degrees Fahrenheit. It's cold here today, but the weather here seems like a walk in the park compared to the polar ice caps of Mars, right? So here is an image of the southern ice cap. And what's really cool about the ice caps is that they actually fluctuate due to seasonal changes. So Mars also has an axial tilt. It's a fancy word for where the planet is tilted towards or away from the sun, right? So Earth has a 23-degree tilt, and Mars has 25. So its seasons are really similar to Earth, but Mars takes about 687 days to go around the sun just once. So that's about twice as long as the Earth. So twice as long to orbit means that the seasons are twice as long. Right, so it's a rather long year compared to what we're used to down here. So the seasonal changes cause some of the ice to warm up, and it actually ends up in the atmosphere for a short time. So sometimes Mars has clouds, which you can see here. And I think this image was taken by the Mars Global Surveyor. And you can see these white areas are clouds. They're mainly water vapor and dust. So I think this is pretty cool. So this begs the question, well, how do we know all of this really cool stuff about Mars, right? So we have been sending crafts and probes and stuff to Mars for a very long time. There have been about 56 missions to Mars or more, my count could be off, to study a wide range of things, right? Though only 26 were actually successful. So orbiters were the first types of probes to be sent to Mars, and the first bound of them were the Mariner spacecrafts, right? And most of them had orbiters. I think some of them might have had others, like detachments and stuff, but I'm not exactly sure about them. Since there were so many, I didn't do a bunch of research on every single one. But down here, you can see the sides of the spacecraft with this astronaut, right? So the Mariner spacecrafts were sent in the 1960s, and they were used for flybys mainly, and they returned very stunning images of the Martian surface. Like this from the Mariner 4 is showing craters, and this from the Mariner 9. So these were the first very high resolution images that they had of Mars, right? So another orbiter that was sent was the Mars Global Survey, which I mentioned earlier. It was launched in 1996. So before I go into that, here on the left is an image of Mars from the Mariner spacecraft upon its when it was approaching, and here is an animated version of its approach towards Mars. I really love this GIF because it seems kind of ancient, but these were the first images of Mars. It's really cool. So now moving on to more modern technology, we're talking about the Mars Global Surveyor. So it went to study the surface and the atmosphere and also the interior of Mars. So it provided really, really high res information of the surface here, right? So here are some images where it's taking pictures of craters and crevices, and it's just beautiful. Like you can see some of the atmosphere and stuff here. I love this. It's so cute. It's smiling at us. We are happy to talk about Mars. So one of the coolest things about the Mars Global Surveyor is that its studies showed that there was outflow and channels. This is evidence that there was liquid water on Mars. So we have a higher area here, and we have these channels that go down to this depression here. And here is another one where it looks like some sort of waterway, either a river or a stream or something, and it looks like it has dried up, which is really cool because most of the probes and stuff that we sent to Mars, we're trying to look for signs of life. So water was a very important part of that. So there were other landers that were supposed to be sent out to dig for ice at the polar caps, Deep Space 2. Unfortunately, these missions were not successful due to the loss of contact with the spacecraft when it arrived. But we weren't discouraged by that because we started sending landers. So this is a picture of Viking 1, which was launched in 1975. So this is a really cool image and might be the first image of the Martian surface that we have. And it's absolutely stunning. I couldn't imagine getting this photo back and seeing the Martian surface for the first time, right? So there was also a Viking 2, right? This lander was sent to look for signs of life in the surface. So what it would do is take samples of the soil and analyze it, right? So they never really found any life on Mars, but this information coming from these spacecrafts was very valuable for our future missions and other landers. And here's another photo. So the next lander that I'm going to talk about is Phoenix. So we had images that suggested that there was liquid water on Mars. Phoenix verified the existence of water ice and traces of possible energy sources for life in the soil, which was really cool. But unfortunately, we still didn't find any microbes on Mars. Here's another version. And here is some soil that it was digging into. Right? So along with landers and orbiters, we can talk about the cooler vehicles that we sent to Mars, the rovers. So now that we have rovers, we could explore the planet in depth more than we ever had before, right? So the first rover was the Sojourner rover. And this was sent with a Pathfinder mission in 1996. So this was the first vehicle that was ever used on the surface of another planet. Pretty cool, right? And we'll see later how small it is compared to the newer rovers, right? So the next one was Spirit. This is one of 2 rovers that were sent in 2003 to search for signs of past life. And they spent years analyzing the surface. They very well surpassed the original 90-day mission expectancy. And I think it worked for 6 years or so. It worked for a very long time. So it was finding evidence that, you know, Mars wasn't always barren and dry. It actually found evidence that it was a lot wetter. So here is an image of the surface, and here's a panorama. Okay. So unfortunately, its mission ended in 2011, though this is actually the last panorama image that the Spirit rover sent. So such a beautiful image, right? So last but not least, we're going to talk about Curiosity. Now, most people know about Curiosity. He's very famous for his efforts and work, right? So he's formally known as the Mars Science Laboratory Curiosity rover, but we like Curiosity better for many reasons. This was the most technologically advanced rover ever built, right? And its mission, well, as the rest were, to determine if Mars was ever or could ever be habitable for microbial life, right? So it landed in Gale Crater in 2012 and has been working on that mission ever since, right? So he has a lot of really cool stuff. I think he has a lab inside of him so he can test some things. He has multiple arms, you know, he has a cool camera up at the top here that you can see. He actually took this as a selfie and at one time saying happy birthday to himself. So we love Curiosity. He's the best rover, right? So here are some images of an orbiter that was going over the surface of Mars and actually caught Curiosity in its imaging. And here's a closer image. So you can see here that they found Curiosity going around, and I thought that was really cool, right? So here are some images, some beautiful images that Curiosity has sent back to us. And Curiosity has given us so much information that's just amazing. So we know so much about Mars now, right? So here's a size comparison for all of these rovers that we have sent, right? So we have Sojourner here, and then Spirit, and then Curiosity. So we can see like how large these crafts were. So it cost billions of dollars to get these crafts and lots of painstaking instruments. Like it took people forever to get everything in order to get all of these crafts onto the surface of Mars, because that's a lot of money, and we got to make sure that everything is perfect. One thing messes up and the entire spacecraft can't land. That's a lot of money in the hole. So they're very important to us, right? So like this was back in 2012. So what's going on now, right? We have we've been looking for signs of life on Mars for a very, very long time. So to harbor life, we need to ask, what do we need, right? And astrobiologists have said, well, water is really important, but we have seen there's evidence for water, but there's no actual liquid water on Mars right now. It's very barren and dry with large plains, planet-wide dust storms. It doesn't really sound like a good place to live, right? Though the information from these spacecrafts that we have sent, we have so much information about the red planet. So is life possible on Mars? Has it been possible in the past? Well, the short answer is we don't really know yet, right? But what we do know is that the surface does have evidence of a more hospitable environment in the past. It might have not been a day on the beach, but in the past, there might have been a better environment for life, right? So right now, Mars is very cold and dry, and it lacks what we would need to live there, but that doesn't mean we can't go visit. So there are teams, you know, engineers, biologists, astronomers, physicists. We're all working on a way to have human missions to Mars. So imagine living in a time where you can see humans walking on the surface of a planet other than Earth for the first time. That's really cool. And we definitely have Mars in our sights, and it's a very, very cool planet. And I can't wait to learn more about it, right? So we do have all of these missions going on now. We're talking about future missions. We also have plans for a new rover. It's a Mars 2020 rover, or Perseverance, which I actually have a link for that I posted before this. So if you want to have information on that, the link is in a pinned comment. It's like a car-sized rover, right? And it's going to be great. It's going to be very technologically advanced compared to Curiosity, and I think it's going to have multiple labs in it. It's really cool. So are there any questions about anything? I know I just put a lot of information out.
Thank you, Jenny. There have been some questions. Most of them were answered, but I'll run through them just briefly for our YouTube viewers who can't see the discussion. Do we know if any volcanoes on Mars are still active?
Well, there was evidence that there was some activity, but it was just seismic activity. I don't think that it was specifically volcanic. Most of the volcanoes on Mars have been extinct for a very long time because of the lack of heat and the lack of activity in the core of the planet since it was so cold.
Yeah, that's a even better answer than the one we have in the comments. The volcanic activity has been extinct for probably billions of years, but seismic activity, yeah, we have seen evidence of that. A rough idea of how much the ice caps shrink or grow throughout the seasons. We talked about that. I think the rough estimate is 25% or so. There's a link in the comments for the Wikipedia article that shows actually a GIF of the caps growing and shrinking.
I was trying to find something that was very concise for that. I kept getting a bunch of unreliable sources though. So if somebody else has a link for that, that's great because I was not able to find one. So thank you very much. Mm-hmm.
Oh, discussion on Mars's moons. You mentioned that Phobos is slowly spiraling inward and will crash into the planet. And Deimos is slowly spiraling outward. People are asking like how long that there was expression of disbelief, and then also how long on the order of years that would happen. I think it's on the order of thousands of years that this is going to happen.
It's definitely not millions or billions, but we are not going to see that in our lifetime.
Yeah, it's but in terms of the scale of the lifetime of a planet, that is quite soon. Thousands of years is a moment. So it's kind of cool that we get to live in the moment where we get to see the little moons around Mars. And I think, was that it? Guys, did you guys see any other interesting?
I want to thank everybody for letting me talk about Mars. It's my favorite planet ever, and I could talk about it all night. So if you have any questions, I will stay here afterwards. So thank you very much. And with that, I'm going to hand it back to Kurt and Tiffany.
All right, thank you, Jenny. That was wonderful. I always love hearing about Mars, and I learned stuff from your talk. So thank you so much. Oh, another comment was Curiosity is solar powered, and I'll let Jenny address some of the other questions in the comments. But we should wrap up. Kurt, did you want to say anything?
No, just congratulations, Howard. I'd play pomp and circumstance, but it's late.
Yeah, we're running over a little bit. I don't want to keep you too long, but thanks for sticking around, guys. I think we've had a pretty consistent viewership today, so thank you so much. I did want to mention briefly, I'll probably mention it next week too. This week we opened up virtual field trips for teachers. So we are offering limited programming for teachers online. If you are a teacher, if you know anyone, tell them to go to our website, to reach out to us. We are hoping to continue our mission to spread astronomy and science education to all of our communities, and especially our teachers right now.
What is next week's show, Tiffany?
Oh, that's right. Of course, I have to announce that. I forgot to confirm this. It's exoplanets, right? We have this all figured out. We're not at all just winging it. Yeah, so our talk next week is all exoplanets. I'm really excited. I think I'm leading the Star Talk. Eleni will be talking all about exoplanets, and then we'll have our director, Dr. Patrick Drell, come back to talk a little bit about the latest technology and how we're learning more about exoplanets. So all things exoplanets. If you don't know what that word means, it means planets that are orbiting the stars you see in the sky at night. So not our sun, not in our solar system, but planets outside of our solar system. So cool. I'm going to be really excited and nerdy next week because I love to talk about exoplanets. I think that's it, right? Does anyone have anything else to say before we wrap up? All right. Well, thank you all so much for another great week, and we'll see you next week. In the meantime, keep looking up.